All right, we are live. Hi, I'm Sasha Chua, and I have John Wiegley on air to share awesome Emacs Lisp development tips. So, John, hi, and take it away.
All right, so Satya and I have been talking about ways to make Emacs more accessible to newcomers and also people who have been using it for a while but might not be using some of its more advanced features. So today we're going to look at beginning Lisp development and what can you do to make programming in Emacs Lisp easier and more enjoyable, because I find it to be one of the most fun languages out there, primarily because of the environment within which I get to work. So I'm going to share my Emacs and we're going to start just showing some stuff. Let's see, screen sharing, Emacs, and let me know when you can see my Emacs. Do you see it, Satya?
Yep, I can see it now.
All right, so we're in a scratch buffer. I'm going to put this buffer in Emacs Lisp mode so that we can play around. And the first thing you'll find when you start out is that you don't want to just use the raw Emacs Lisp mode that comes with Emacs. There are so many cool things that you can turn on and off to make the Lisp development experience much, much better. And one of these, which takes some getting used to, is called PartEdit Mode. And I really have to say you should invest in learning and getting comfortable with PartEdit Mode from day one, because it is truly part of what makes it enjoyable to write Lisp, any kind of Lisp actually, in Emacs. So in PartEdit mode, the concept is that the buffer is always kept in a semantically valid state. So, for example, parens must match. Every opening paren has to have a corresponding closed paren. So PartEdit mode will only insert paren pairs, opening and closing together, and will not let you delete one without deleting the other. So in this buffer, if I type open parens, you'll see that I get 2. And my cursor just changes because of a mode that I have on that makes it an insert cursor while I'm typing. If I then go to the end of this paren and I hit backspace, it doesn't delete it because it wouldn't let me. But if I go to the front and press Control D, it also doesn't let me delete it. However, if I press Control K, I can kill the whole sub-expression. It comes with a lot of key bindings, so I'm not going to try and describe everything that PartEdit can do because there's a lot of documentation on it on a lot of key bindings. I just want to put this pointer out there that that is what I'll be using and it's what I recommend other people do. So let's write a function called foo, and I'm not hitting return or anything. All these extra white space characters are being inserted for me by PartEdit. And we will just say message hello world. I don't think I even typed a single space or return while writing that. And now I go to the end of my definition. Well, while I'm anywhere in the definition, I type Control meta X, and that will evaluate this definition into the current environment. Emacs has the reputation in some circles for being an editor. That's not entirely accurate. Emacs is really more of a Lisp development environment that has a huge number of very well-functioning editing constructs. So it's a great environment out of which to construct an editor, but it is not just an editor. In fact, I kind of look at it as a miniature Lisp machine, if anyone recalls the Lisp machines from the 1980s. So when you're in Emacs, you're in a Lisp environment that has a certain number of functions resident in memory. When you evaluate...
Sorry, can I interrupt you a little bit? There's going to be a Google watermark right over the interesting parts of your text. So can you either add some blank new lines? Perfect, thank you.
Okay.
All right. Lisp environment, yes.
Yeah, so in this Lisp environment, we have a large number of functions that are in scope, that are defined in the global environment. And I can type Control-HF to get access to this list. Now, I see it as a list here because I'm using Helm. If you do not have Helm, you would see no list. You would just get a prompt for which function you want it to describe. But these are just some of the global functions that I have available in scope. When I evaluate a function, I'm adding that definition into my current global scope. If I make a change to this function and evaluate it again, I'm updating that definition in the global scope. So you can see the global scope as being this mutable state that Emacs has and provides you with, that it's full of functions and commands and things that you can do. So now I can type meta xfoo and run my function and get goodbye world. I can change it, reevaluate it, hit it again. Now it's been updated. And this makes it fantastically easy to iteratively develop your functions. So you develop your function and you put little stubs in for where you don't have behavior yet, like unimplemented or whatever, and I can just keep evaluating and running my function under different conditions and just keep extending the behavior as I go. And so there's no compilation process. There's no need to go to command line and run make or run things from there. You can just execute these functions directly. Now this is for interactive functions. If I reevaluate it as a non-interactive function, I don't get to use it at metax anymore. So that's the distinction between a function and a command. To evaluate just a regular old function, I have two choices. I can do metacolon, which puts me at a little Lisp evaluation prompt where I can execute any Lisp form. So I can call foo as a function down there the same way I would have called it as a command using metax. The other alternative approach is to just put the call of foo directly in the text, go to the end of it, and type Control-X, Control-E. It'd be cool if in this talk we had little like lighters that popped up to show what key bindings I'm mentioning, but that's a little bit too much work for Satya, I think.
There's an NWE log commands or something of the sort, and some people use like the Mac application to overlay keystrokes. But I can probably download the MP4 and layer things in afterwards.
I have command log mode available. Let's do that. Here, let's turn on command log mode, and then where is that? Where is the command log kept?
And while you're doing that, I'm also taking notes using org timers, so we'll have timestamps and everything too, and I'll link them all to the YouTube timestamp stuff.
So CLM open command log buffer. All right, now you can see what I'm doing. So Control-X, Control-E says evaluate the thing that's before point. On other people's Emacs, it's probably not going to be PP eval. PP is the eLisp pretty printer, so that I can see the Lisp structures very nicely displayed. I think it's just regular old eval last sexp for a unconfigured Emacs. If people want to see how I configure my Lisp mode, I have a repository on GitHub called .-emacs, and all of my Lisp mode configurations are somewhere in that file. Just search for Lisp mode. Anyway, so this is how we evaluate, how we would write and evaluate and test out one of our functions. Well, what if I want to debug it? So the other beautiful thing about the Lisp machines is that it is very, very easy to jump into the debugger. You automatically get thrown into the debugger if there's any type of exception that occurs. So I can do this and then call my Lisp function, and I have to toggle debug on error, which says I want to jump into the debugger if there is any type of error. So now I run it, and boom, there I am in the debugger. And in this debugger, I can do lots of things. I can hit E to evaluate any Lisp form I want within the current context. So that context includes local variables. I can step forward. I can step over. I can exit the debugger and let it continue on to do whatever it would have done next. That's exactly the same, actually, as how the Lisp machines used to behave. Alternatively, I can use a feature of Emacs that comes with Emacs called edebug. And edebug is, instead of typing control meta x to evaluate my function, I type control u control meta x. And the control u is a prefix key that says modify control meta x to have some additional behavior. And in this case, you can see down in my mini buffer, it says edebug foo. So I have now established a debug wrapper around foo so that when I call it, I get jumped into the debugger. This is not showing me a backtrace immediately by default, the way the standard debugger does. Instead, in my fringe, I get this little triangle, like this dark triangle over there, and a set of key bindings, because I am now in the interactive debugger. If I type space, it will move me forward one Lisp form. And it will be showing me the evaluation of every Lisp form that I visit down in the mini buffer as I move forward. I can type another key to descend into the Lisp form, and there's even one that will let me go follow a function and continue my debugging over into the function that gets called. Question mark will give you all of the key bindings that edebug supports, and there are many. So there's a section in the Emacs Lisp manual about edebug, and I highly recommend learning it. The traditional way of debugging is to just put the form debug into your function somewhere. And now I evaluate it and I run it, and now I don't need an error to pop me into the debugger. I get popped into the debugger whenever that debug form gets evaluated. interactive debugging is the way to go. I know in some languages, print debugging is a much more convenient and easy way to do debugging, and I do that a lot in other languages. But in Emacs Lisp, they've made interactive debugging so convenient and so easy that it's actually quite a lot simpler to use than the printf style of debugging, which would, I guess, include just outputting these messages to say things like "got here." So you can do that style in Emacs Lisp. It's just not as fun.
By the way, if anyone has any questions about the cool stuff that John is showing, you can use the Q&A app if you're watching live, or you can leave comments on the Google Plus page. Carry on.
Okay, so if I want to call a function like message and I hit space and I wait, you'll see in my mini buffer that it's showing me all the arguments that message takes, and bold is the argument that it's currently waiting for a value for. Now, no one, I think, in all of humanity would be able to remember all of the functions that Emacs supports, because there are thousands and thousands that are available, just even with a stock Emacs. And some of them are confusingly inconsistent. Like forward char, I think, takes a number as no, it takes an optional number, whereas backward char, it's either backward char or delete char wants a one of them wants a this one wants a non-optional number of characters. So I never remember whether it wants a n or it can be done without an n. So you can either just always put the n in there or let this mode tell you what it is, and that mode is called eldoc. And you just do meta x eldoc mode, or in your Lisp mode configuration, turn on eldoc when Emacs Lisp mode gets engaged, and then you will get this auto prompting down at the bottom, which is a huge memory saver. Now, of course, the barrier normally to Emacs Lisp programmers who are just getting started is not which arguments to pass, but which functions to call in the first place, or even the concepts that Emacs uses, because Emacs is a very old programming environment. It comes from the day before graphical environments, before mice, before toolbars and menu bars, and all kinds of sort of UI niceties that have come about. And so over the years, Emacs has integrated these ideas, but at the times it integrated them, there weren't necessarily standard definitions of what these things should be called or referred to as. So one of the confusing things that happens in Emacs Lisp is that you have frames and you have windows. Windows are the opposite of what you think that they are from any other GUI framework on the planet. Windows are just this area within the Emacs application. So the graphical sort of application level window, what I would think of as the OS window, that is the frame for Emacs. The window for Emacs is that area in between it. So right now I have one frame with two windows. The scratch buffer is being displayed in the window on the top, and the command log buffer is being shown in the window on the bottom. A window can display any buffer that you want, and you can make new windows and make windows go away. And you can even create new frames, but I won't do that because it wouldn't show up on the screen sharing. So if you're used to programming in HTML, just take what you know of windows and frames and just reverse it. So there are little oddities like that. The best thing I can recommend is that I know that there's a really good Emacs tutorial for learning to use Emacs as an editor. I'm not as aware of a good Emacs Lisp tutorial. So you can read the Emacs Lisp manual. If we go into info mode, to the info directory, and just go to the Emacs Lisp, oh, look at that. There is an Emacs Lisp intro. Hadn't read that, so.
Yes, it's a good one.
Yeah, so read that, people. That has the basics of writing code in Lisp and working with Emacs. It looks like that this is more focused on just Lisp than it is on Emacs. Does it even talk about frames? No. For that, you would probably have to go to the eLisp manual. Yes, this will talk about frames and windows and buffers and positions and markers. There are a lot of concepts. When you're within a buffer in Emacs, there are a lot of features that you have access to, a lot of things that are available. I want to bring up that. What's the name? There we go. So you have a window. It displays a frame. The cursor is at a position called point. If you had ever set a mark, which sets the other side of a range, where I am is point. The other side is mark. You can have a marker, which is an Emacs Lisp rendering of a position that moves as text gets inserted or deleted. So let's say I want to say here I'm at point, and I want to print it. So let's just say, render me point as a string. Evaluate foo, execute foo. It says 128. So I'm at position 128. And if I hit Control X equals to say what is my cursor position, yes, I'm at 128. If I say marker, point marker, yes, run foo, I have to evaluate it. Now I'm at the same position, but it says, instead of just being a number at the bottom, it says marker. And the difference between a marker and just a numerical position is that the marker can shift. If you insert text in front of it, the marker will update its position to include the newly inserted text. Now, that might be getting too specific. So let's look at other discoverability features here. Once you figure out what the function is that you want to call, so let's say I want to call point marker, but I forget what are some of the details of its semantics. You can type Control-HF to get help on the function that you're currently at point for, and then hit return, and you will see the documentation for that function in the other window, the help window. And this is the truly awesome thing about Emacs. Nearly all functions that you would want to call from the standard library are documented, and documented very well. The interactive form, for example, for making something into a command, takes tons and tons of options that I cannot remember. So I can always just bring up the help for interactive at any given point in time. And it describes all the condensed summary of just what it is that I want to know to pass something to interactive. So I know here that interactive takes a string, and that string specifies a series of code letters, which will give you sort of behavior on, oh, I want to prompt for a directory name. So now if I go and I run foo, I have to call foo as if I have to call foo interactively for this to happen because it's in interactive form. Oh, it's not prompting me for a directory. Oh, sorry. Capital D. That's why I got that documentation open. Now I'm being prompted to enter a directory. I did not give any prompt text. So that's the easy way to. So now as a Lisp function, I can just call it with a directory name. But as a Lisp command, foo knows that it wants a directory for that first argument, so it will ask for it via the interactive form. This works for variables as well. Let's take a variable. Buffer name is a good variable. Buffer name is not a good variable. For file name? Okay, buffer file name is a variable. It actually happens to also be a function of the same name that returns the same value, but there you go. So both functions, variables, commands, they can all be you can just look up their documentation right away. If you want more in-depth documentation, you jump over to the eLisp manual, you type I to access the index, and you look up the function that you're interested in. And now you'll get exhaustive documentation on what interactive can do and what all of its arguments possible are. And all the other things that Emacs knows what to do. Like, let's see, interactive codes. These are those single-letter codes. Here I get much, much more documentation on what every code is going to do and provide. So there's a really nice package out there. I know it's mentioned on the Emacs wiki called Info Look More, and I don't have it currently set up. Let's see if it'll work. Info Look More gives you this. Yeah, I don't have it set up. It'll give you the ability to take the symbol under point and just jump you straight into the documentation in the eLisp manual for that symbol. So I had that set up at one point, and it worked great. But because it works for other Lisps too, you can also have it set up to jump you into the Common Lisp spec, for example, for that function, which works great if you're using the Common Lisp library inside of Emacs to remind yourself what some of those functions do. So do you have any questions thus far, Sasha?
No, although I would like to take this opportunity to point out that if you wanted to prompt for multiple things with interactive, you could use line breaks /n to add more things to ask for, since that's something that often comes up. And we have 12 viewers online. So again, if there are any questions, feel free to ask, and I will bring them in at the appropriate moment.
Okay. So let's look a little bit more at our beautiful PartEdit mode. So as I said, PartEdit is sort of stopping me from getting this buffer out of whack. Another thing you can do to just do a sanity check on a buffer is metax check parens. And check parens will make sure that all your parents balance. That's really all that it does. And so in my Lisp mode hook, the functions that I use to set up my Emacs Lisp mode, I have check parens run after trying to save a buffer, so that I never have, so that I am able to save the buffer, but it'll always give me an error if I have somehow saved a buffer that has mismatched parents. And you may ask, well, how is that possible, John? Because PartEdit is making it impossible to do that. Well, there are things PartEdit will let you do. For example, I can select a region and delete it. And now I have mismatched parents, so if I run check parens, I will get an error. And it will move my cursor to the place where it discovered the error. So PartEdit does not basically solve everything. But there are a lot of other cool things PartEdit does. In this notion of maintaining semantic consistency, it gives you editing capabilities. So for example, if I type Control-K, which would ordinarily kill a line in other buffers, here it means kill the current sexp, because that's the only semantically meaningful definition of sort of a line in Emacs Lisp mode. If I do it up here, well, it'll delete a lot more. What if I'm on the message thing and I want to lift it? Well, there's a way to just take the current sexp and replace the parent sexp with it. I probably use that feature of PartEdit more than any other. I can, if
What's that one called?
that one is called PartEdit raise sexp, and I have rebound that to Meta-K because I don't use whatever Meta-K does. For me, that says kill everything else and pull my guy up. There's another concept in PartEdit called barfing and slurping. So you're in a Lisp form, and in this message call, I have 3 members of this Lisp form. Barfing is the idea of spitting out an element from the Lisp form. So it's by default set to control open and close curly brackets, curly brace. If I do it, what it does is it just takes the last element of the form and spits it out. And I can keep repeating that key and spitting more things out. If I do parens instead of curly braces, that is slurping, which says pull it in. This is also a feature. I don't use barfing as much, but I use slurping all the time because I'll be somewhere else and I'll say, you know, foo, and I'll realize, oh, I want that to actually be up here, so I'll do like that. It works inside strings as well. So it's not just for Lisp forms. Let's see. It does not let me barf out, but it does slurp in. Yes, because it can't figure out the semantic constructions within a string. There are some features I've added to PartEdit on the wiki, which are maximum barfage and slurpage, which says take from where I am onward, barf it all out, or slurp in as far as you can. Like slurp as many things as you can until you run into a open parent. And that's useful where, let's say I have like this, and well, now I want to I could just keep hitting the commands to bring them all in, or I could do maximum slurpage, which, you know, I may not even have maximum slurpage currently configured. Oh, all the way, that's what I call it, slurp all the way forward, there. That just sucks everything into, and I apparently have it bound to control meta open parent. Just slurp all the way as far as you can. And likewise, if I'm here, barf all the way out. So that's a really nice way to just cut things out of your prog end. Especially if we had, say I have this if, and I realize, I want all these things to be guarded by the if. Well, let's just slurp them all in. Or I want to cut it right here. Now let's just barf those guys out. But very easy, something that if I were using just raw editing without PartEdit would just be manual. I'd have to type parents here, parents there, change everything, make sure all the parents lined up, etc., etc.
Yeah.
There's also a companion library to PartEdit called Redshank, and Redshank provides you some very simple refactoring capabilities for Emacs. And I have to say that I use Redshank so rarely that I always forget what it can do. Okay, so this is one that I do use when I remember it, which is I have this if-t, and I realize, oh, there's actually 3 cases I am going to want to I'm going to want to do. So I want a cond here. I don't want an if. So I can type Control X, Control X, Control RC, and that will condify my if, so that I can now add in more stuff. And then, of course, I can slurp in here to make BAS be at the testing level. I'm surrounding things by parens by pressing a numeric prefix. I do meta1, meta open paren, which says surround the next one thing with parens. I could also do here, I could do it for two things. Another common keystroke. Let's see, what else can Redshank do? Redshank can also letify a form, so turn something into a variable setting. It can turn an if into a when. If you realize that you only have you don't have an else clause to your if, and you're tired of if progn, and you just want to stick all that under a when. It's also got features for it looks like EIO. And then also it has this maybe splicing in a progn. Now I don't remember what splicing in a progn does. So let's ask Emacs, what does it do? I'll do Control H K to get help on what function is bound to a key, and I'll type in the key. Now I can see splice the progn format point into its surrounding form. All right, so I have a progn here, and I want to do what this will do. So I did meta3, meta-k, which says lift the next three forms up. But what if there were many and I didn't want to have to count? Now I can just say wherever I am, Control X, Control RP. So my point could be anywhere within the progn, and it just takes the guts of the progn and lifts it up.
Marcin wanted to know what's the screen you've got now. I'm not sure what he means, but anyway, that's a question.
What screen?
Yeah.
Can he clarify?
Marcin, do you want to follow up with another question along those lines?
What's that? Say that again?
What is the screen you got now?
Does he mean the monitor I'm looking at?
I'm not entirely sure, but when he posts a follow-up question, I will relay it, and you can, in the meantime, continue.
Okay. So let's turn our if back into an if, but using manual things here. So we want to barf out the T. We want to lift up the progn, lift up the bar, lift up the BAS. All right. So that didn't take too many keystrokes, but was easier than would have been otherwise. So that's the beauty of Part. And it is very difficult to get used to. I think it took me several weeks to sort of stop doing everything I was used to doing manually because PartEdit was doing it for me. But you get into this sort of zen of PartEdit where you just basically never deal with parens anymore. Parens are dealt with for you automatically. Let's see, we've covered the debugger. Another nice thing that Emacs provides by default is the Emacs linter. So I type meta x elint current buffer, and that will load in every single module that my code depends upon in any way, whether explicitly required or not. So the first time you run it, it's slow. And then it will lint the buffer and give you any stylistic problems that are in the buffer. So here it tells me that I'm referring to variables without having declared them. So I might want to then go into my buffer here, get those into my guy, delete the rectangle, insert a rectangle, and then just say, so the way you can type a paren without bypassing PartEdit is to type Control Q, which lets you insert any character literally. All right, now
so Marcin has a clarification. He was probably referring to Helm. So he's yeah, he said it was the screen when you were selecting some stuff with a blue bar on top. That definitely sounds like Helm.
Yes, this is Helm. This is Helm.
Okay. All right.
Helm actually makes Emacs Lisp programming much, much nicer because you see this nice little list here you can interact with. And in fact, I can go to a thing, say, oh, I want the help on that, and realize, oh, that wasn't the one I meant. Go back to the Helm, select, oh, it doesn't work for describe function. Never mind. Actually, we discovered that in our last discussion.
I'm sure someone will hack it to actually work eventually.
Right. So It works in other Helm modes. But anyway, yeah. So Helm, the nice thing about Helm is that it shows you all the other things that could possibly be an answer to your query. And it allows you to select by regex as well. So there are very few things that begin with interact. It allows you to have 2 patterns to match against. So I want things that contain both interact and skip. The default mode for this prompt is just a blank question. And you can type some things and you can type tab. And it will show you a list of all the things that begin with inter. But using Helm, you get a much, much nicer and more interactive experience. So Helm is a whole discussion unto itself, and I think Satya and I will probably cover that in on another day. But you will see me using it for many things. Okay, so we discussed the linter. There's also a profiler. So I can type ELP to instrument my function. And I will say instrument foo for me. And now I'm going to call foo. And I'm going to take a little while to answer this question. Hum-de-dum-de-dum. And now I say ELP results. And it will tell me how many times my function was called, how long it took, how long was spent by the Lisp evaluator in evaluating that function. And this includes time spent by foo waiting for me to answer the question. No, actually, it does not. It does not include that time. Sorry. That's handled by a different event processing framework. And then the average time that it took to execute. So the time you see here is just the time it took to output the message foo. Output the message that foo produces. And if I were to call foo multiple times, so let's keep calling it, these results, they aggregate. So I get 2. But they reset after I get my results. And then if I want, I can say ELP reset all, which says unprofile all my functions and just go back to their ordinary behavior. So if you find, for example, that GNU's is running really slowly on you, and you want to know where is GNU spending all that time within the Lisp evaluator, you can just say ELP instrument package, and then say GNU's, and that will say instrument every single function that begins with the letters GNU's. And then you go do your stuff in GNU's, and then after you're done, exit GNU's, run ELP results, and you will get a very nice tabulation of where GNU spends its time. So if you're writing any package of any size where you're noticing latency or performance issues, the Emacs Lisp profiler makes it very, very easy to track down who's bringing in that slowness and why. Now, something that's slightly less easy to debug by default, by default I mean with what comes with Emacs, is memory consumption. There are different ways of doing things in Emacs Lisp. Let's say we want to build a list here. I want to loop for I in 1 up to 10, collect I. Now this loop macro, let's see. This loop macro comes from the world of Common Lisp, and I may be using this wrong. I always go to a website called Loop for Black Belts.
I always just copy things from other people's code.
Right. Okay, so it's for I from 1 to 10. All right, so you can see in my mini buffer that this just enumerates all the guys from 1 to 10. But I realized, oh, I don't want 1 to 10. I want 10 to 1. And instead of fixing my loop macro, I'm just going to reverse the list. Now, Emacs Lisp doesn't tell you that this is the wrong way to do this, because you have a list. Well, a list here you're constructing by loop that is building. It's building up const cells, and a const cell in Emacs Lisp or in Lisp in general is just a sort of a node within a linked list that has a car and what's called a cdr. And so you might have the number 1 in your car, and then your cdr might be another const cell, which might have as its cdr another const cell, and then finally a cdr of nil. This is what is internally represented by 1, 2, 3. So every const cell takes up memory, as well as representing the integer atoms here. Although the integer atoms, there's possibility that the basic ones might be shared. But let's assume that they're not shared. So we have memory being used by the const cell, by the number, by the const cell, by the number, const cell number, and by nil. So we're using up 7 little bits of memory that have some size of n bytes each. Now when I call reverse, reverse builds another list, which is a reverse of the original list, by basically just walking through all the const cells and doing what you expect. And this also takes up these 7 bits times whatever factor n memory. So in total now, I'm using 14 of these things. But the inner 7, the original list produced by loop, gets thrown away immediately after the reversing is done. So it's kind of a waste to build up this whole list only to build up another list of the exact same size. So Emacs Lisp has a function called nReverse, which says, I know that the list that I'm reversing is not going to be used by anyone else but this reversal function. So instead of creating a new list whose contents are the reversal of the old list, just reverse the old list in place by mutating it, by changing the const cells directly. And so that means that the overall memory usage is going to be exactly 7 bits times n. So just by going from reverse to nReverse, I have halved the amount of memory that I will use. And so what you will find sometimes is that you write a module, it's doing great, everything works, you run the Emacs Lisp profiler, and some of your functions are kind of slow, and you wonder, well, why are they actually slow? It doesn't look like I'm doing anything wrong. It might actually be that you're creating a whole bunch of throwaway const cells behind the scenes, and the time being spent by your function is time in the garbage collector, just to get rid of all of these throwaway const cells that you've made. And so there's a family of functions, usually beginning, say, with n, like nconc and nReverse, that will let you mutate things in place where you know that those const cells being mutated are seen by nothing else, no one else but your mutating function. There's also setcar, setcooter to directly manipulate const cells. And so there have been times where I've written a package and it's quite slow, and all I do is I sort of do a code review through it, and I add mutation in the places where I know it's completely safe to do so, and my module becomes 10 times faster, because now you're not triggering the garbage collector, which can be slow depending on how much has been going on in your Emacs between garbage collections. So that's just something to be aware of, and unfortunately, there are if you look for memory counts on Emacs Wiki, there is a module that tries to make it easier to show you what's going on. There is a function called memory use counts that will give you this unhelpful list of numbers, and if I look at the documentation for memory use counts, I can figure out what those numbers are for. There's a module out there which extends the Emacs Lisp profiler so that in the profiling results, it also gives you what that function contributed to every one of these numbers over the course of all of its executions. And that can be really helpful. And then if you see one function that's just ballooning out const cells, you could be doing something like an order n squared loop, where you have a loop within a loop, and both the inner and the outer loop are generating and throwing away const cells like mad. So that's just something to look out for when you get into the point of caring about performance. But I think if you're just starting out with Emacs Lisp, don't worry about it at first. Just use the safe functions. If you try to optimize in advance, you may find that you have this list you created with loop, and then you nReverse it, and then somehow you end up giving back to your caller both versions, and you realize, wait, one of those, but both of these are reversed. Because this call to nReverse reversed X, and then this is the reversed X, whereas this returns one reverse list and one unreversed list. So don't use the optimal nReverse function unless you really, really know that you're the only consumer of that list.
Martin was wondering if Elint's integrated with Flightcheck or anything similar?
Yeah, there is a Flightcheck integration for Elint, I think. Let me see here. Let me see if I actually have that set up anywhere. The problem with Elint and Flightcheck, well, at least the last time I looked at doing that, is that Flightcheck was originally designed for running checkers that execute as external processes to your Emacs. And ELINT is written in Emacs Lisp. So that would require Flightcheck evaluating code that might lock up your Emacs in order to do the linting. So it may be that right now, today, that isn't available. The other possibility for people that might be curious is using the async module that I wrote to spawn off a different Emacs that will just go ELINT your buffer and feed the results back to Flightcheck. So that, I am afraid that Googling right now, I don't see any other better answer to that question.
That's cool.
Let me take a look at my Emacs Lisp mode to see what other things I'm using. ERT is a great package. Sacha, do you have some things you would like to tell us about ERT? Because I know you use that, and I have not been using it lately.
Only that it's awesome. I've seen more and more libraries now start using it to do automated regression tests. So the nice thing about ERT, which actually, let me see if I can share my screen here. Share Emacs, share. Okay, let me think of my evil plans have a little bit of an ERT test in them. Hang on a second, dev test. Okay, so what ERT does is it allows you to define very simple tests which you can run with MetaX ERT, and you can also run them outside an interactive Emacs session by using ERT Runner. Here I'm saying that this Sasha lgraphviz process property list should take this as a argument, and the result should be width equals 1. So by having this def test, what I can do then is I can say ERT and then run whatever tests, maybe all the tests if I specify T, or I can specify a specific test. I can specify a test to run just that, which naturally fails. Let me just actually evaluate all of this stuff. Val buffer. The challenge of having blocks that are meant to be run inside org.babel. Okay, all right. Anyway, thing. Hang on a second. Let me. Does that now let me run my test? This one. Yeah. Okay. So when the test passes, you will see the tests that pass, and actually you will see the tests that fail, especially. So if, for example, my ERT test here, process property list. If I say blah, 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 this becomes now a test that I expect will fail. When I try running ERT, it should show me that it failed. It will show me what I actually got and what I expected. So that's ERT for you. It can test a whole bunch of things very quickly.
Very nice. So it's it's a unit testing framework.
Yes.
Does it provide any mocking capabilities?
I actually haven't even gotten that deep into it. Probably, like, if I needed to mock something, I could maybe just do the evil thing and redefine it. I don't know. But if you look around for other people who have more sophisticated uses of ERT, org mode uses ERT extensively, I think, and Magnar Sveen has a couple of libraries that use ERT quite thoroughly as well, I think. So you can go and check them out.
Okay. There's also on the Emacs wiki there's a EL mock, which will let you say that if this form should be evaluated at any point, then return this result.
Yeah. Okay. And then if you want, you can even visualize your test coverage. The precise process for which always eludes me, but I think if you look at test cover, oh yeah, you can say test cover this defun. So let's say, for example, we have our, I'm in a scratch buffer. Let's say we have our defun weird function here, and we say if t then message hello world, message. How did I get here? Okay, so this is our function. And if we say test cover this defun, it actually debugs it. And then if we call a weird function, theoretically there's something for, so I have to say mark all, yeah. And then this shows me that the red splotch over here says this stuff was never executed. So that's weird, and therefore you can see where you're, when you run things, which parts of your code don't get exercised.
Interesting. And this is provided by which package?
I think it might even just be built in. Let me go find out. I'm using a describe function, Control HF, to look at test cover this defun. Test cover.el is in.
You're right. It's built in. Huh. Never even knew about that package. Thank you.
So if you use this and you want to be all, fancy and have a coverage badge in your package repository, you can use a separate package called undercover.el. I have a blog post about this somewhere. So if you search for undercover and your coveralls on my blog at sashachua.com, you'll find it. But basically, you can get this fancy schmancy badge from coveralls IO, which naturally I'm not screen sharing. Hang on a second, let me share more of my screen here. Share. So if you wanted to report your test coverage, not just for yourself, but also for everyone to look at, you can use a service called coveralls.io and a package called undercover.el. And what that gets you would be stuff like, hang on a second, let me go find somebody I've added such a coverage thing to. So here, you can see here that Abo's build is passing, which is handled by Travis, and his coverage is 89% of this Emacs Lisp function, Emacs Lisp library. And then if you click on the coverage badge, it'll actually show you which lines are covered. So if you have an Emacs Lisp package that's hosted on GitHub, you can see all these lovely stats.
That's very cool.
It is. Anyway, so onwards to more professionalism and automated regression testing. Okay, we've got about 12 minutes, I guess. Actually, I can keep it going forever, and we'll probably schedule more sessions after this. But were there other quick exploration tips that how to explore and develop better Emacs Lisp code that you wanted to squeeze in today?
Let me think. So the main ones were to spend time up front learning PartEdit and learning edebug. I think those two will give you the biggest payoff. Read the Emacs Lisp intro, and then after that, and if you already know another Lisp, you probably wouldn't need the Lisp intro. Then reading the eLisp manual itself, just to know what all the capabilities are that are out there. So for example, what the different types of constructions that Emacs gives you are. Okay, here's another one. That a lot of the time what people want to do with Emacs, besides just writing some new command or some new function, is they want to create a mode. They want to have either a major mode or more typically would be a minor mode. So writing modes has a lot of requirements. There's a function define. Is there a major? No, define. There is no define major mode these days, but there's define minor mode. And it's got a lot of things that it wants, and et cetera, different keywords. What I do when I want to make a mode is I do not try to make a mode from scratch. I find a mode that does something similar to the mode I want to write, and I just copy their code and start modifying it down, sort of strip away everything else that they're doing that I don't want to do, and then add in what I do want to do. So I do not know that I have ever written a minor mode from absolute scratch before in my life because, well, I mean, that would just require learning how to do all of those things when why? There's people who've written minor modes left and right. Let's just go find a minor mode that comes with Emacs. So we're going to go to that test cover library, and we're going to grep for define minor mode. So let's find a minor mode that comes with Emacs. And there, checkdoc is one of them. So checkdoc is that mode that is providing that little on-the-fly documentation. So we see here the basics of what we need.
Sorry, checkdoc is the one that checks the style of your documentation?
Oh, yeah. We hadn't used checkdoc yet. Checkdoc goes for, so functions, I didn't show this previously, but when you define a function, you can also include documentation. And then if I evaluate foo and I type Control-H-F foo, now I get to see that I have documentation. And also I can see that it's still being instrumented by the Emacs Lisp profiler. So let's see, let's restore it, and now look at the documentation. And there, all I have is my documentation. Yay. I don't know if you can see that. Here, I'll put it down.
Yep, works for me.
All right, so if I go now into this function and I say checkdoc, it will tell me that I have not even mentioned my argument. So let's say this is documentation about directory, and Emacs has this convention where arguments get capitalized in your documentation. Now I check doc again, and everything is okay. However, I have no comment to describe all of my buffer, so it did not check it, but everything else worked. So anyway, what is checkdoc? Checkdoc is a minor mode, and
yes. And then you can just copy this and do stuff with it.
yeah, you just slurp it out, grab it, stick it here, say my new minor mode. This is my first minor mode. Let's do, and usually you want to show the documentation for your minor mode map. And then let's go get the mode map. Okay, we get this easy menu define, which not only defines, oh, that's for making menus. I don't use menus. Never have, never will. All right. Cursor. Grab the mode map, and then we're going to say that the key, oh, let's see. Let's just make a simple mode map that says control question mark is going to run our foo. We will delete everybody else. And we don't need documentation, it's just optional. And we have and we need a minor mode string, so my minor mode map, and then my new minor mode map string is going to be hi. All right, and the group, we're just going to put Emacs for now. So we're going to control meta X to evaluate the def var, to evaluate this def var, and to evaluate the minor mode. And you'll see that that resulted in a huge thing. You can just ignore that. Now I can type my new minor mode, and you'll see that in my mode line there is this hi, and I realize it needs a space. So let's go ahead and add that space, and it updated that live. Now what does being in my minor mode mean? Well, it means that control question mark should be defined, but it is not. Let's find out why not. This is where I would have to dive into the documentation because I have not made a minor mode in recent. Anyway.
That's okay. We get to see you figure things out.
Yeah, so let's do that. Let's just go into documentation here and say mode map. Optional key map is the default key map bound to the mode key map. If non-nil, it should be a variable name. So
that
key
sounds
map,
like it should be something.
Nil doc init value mode doc nil. Oh, should be just an argument.
Why do you end up with those curly braces?
Oh, it's because I'm using hippie expand.
Oh, I see. And it's pulling it from the doc string.
Right. So now if I turn in my minor mode, still my control question mark is not being.
Did you turn it off and turn it on again?
I did.
Oh, hey, it's Dell.
Yeah, but it shouldn't be del. So let's try something else. Let's try meta capital S. So let's turn it off, turn it back on. Now meta capital S is foo. So I do capital S.
Okay.
It's not a command. Well, we know how to fix that. We want it to ask for a directory. Okay, let's reevaluate. Now, there we go. And if I turn my minor mode off, now meta capital S does what it does in PartEdit, which is if I'm in a form, split the form at the point where my cursor is, so that it becomes two different forms. And there's another one, meta capital J, for joining two forms together. But if I go into my minor mode, now it's foo. So that's the beauty of a minor mode, is to selectively add in key bindings as you want to any particular minor mode, to any particular major mode, without having to define that key for all modes globally.
Right. So in addition to using it to add key bindings, or you may maybe be able to turn certain sets of key bindings on and off easily, you can also use minor modes to add your own behavior, like the way that auto revert mode automatically reloads a file when the underlying file changes. So there are lots of things you can do with minor modes. When would you recommend using a major mode instead? When would you define the new major mode?
So a major mode is usually when you want to describe a modality which should be true for the nature of the text that's in the buffer. So for example, dired mode is a mode for editing the contents of directories. And mine doesn't look like what everybody's is going to look like because I have all these extensions turned on. But it doesn't make sense to treat the contents of this file as text. They should be treated with a special semantic meaning, which means entries in a directory, so that as I do things to these files, it should be doing things to the underlying directory. That indicates a major mode. A minor mode varies the behavior of a major mode, but the major mode defines what the text in the buffer means. So if I'm editing in a programming language, like we go here over to Haskell, I'm in the Haskell major mode, which says this is Haskell code and these things are true about Haskell. And now I might have many minor modes also turned on, which add features to Haskell mode, like looking up documentation or automatic completion and things like that. But the major mode is sort of setting the stage for what the meaning of what I'm seeing in the buffer is. If you provide no major mode whatsoever, there is a mode called fundamental mode, which is nothing. I mean, it's just basically the most raw and basic mode possible with no minor modes turned on by default. The only key bindings you have in here are the global bindings. I don't think that fundamental mode gives you any fundamental mode related bindings. It may. I don't know how the structure of fundamental mode is. But all other major modes, they have a hierarchy, and they can descend from each other. And all other modes descend from fundamental mode. So if you add a function, a minor mode, to the fundamental mode hook, it will cause that minor mode to be turned on globally, for example. Some of the other more basic modes is, well, so fundamental mode is the most basic mode. The next one up would be, I guess, text mode, which says the nature of the contents of the buffer is some form of text. There's another one which says prog mode, so it's some kind of programming languagey thing is in my buffer. And then you have other modes that are just totally special, like dired mode or proced mode for editing processes, etc.
So if people want to learn more about modes, you can always use Control-HF to look at the documentation for define minor mode or any other things. Or you can actually use Control-HF to take a look at your favorite mode and then jump to the source code for that. We're coming up to the end of our hour, so thanks, John, for sharing all this stuff. There are, of course, a ton of other topics to cover in Emacs Lisp development, such as macro step and macros, auto-completion, that Tippy expand that you were using earlier. So we hope everyone will join us next time for another episode of these Emacs Lisp development tips and other cool things. So yeah, any parting words?
No, I guess, I mean, I don't know if we went a little too deep for people who are just starting in on Emacs Lisp, but I hope there was a little for everybody.
That's okay. If people are curious and they want to find out more, there's always the Google Plus event page, the YouTube comments, Emacs Stack Exchange, which is turning out to be a really good community, the Emacs help new Emacs mailing list, and all sorts of other places to ask for help. But Emacs is lots of fun, and I hope the tools today will help people kind of have a better Emacs list development experience.
Yep.
All right. I'm going to end the broadcast here. Folks can check out the YouTube replay, and I will post notes shortly. Okay. Bye!
Bye-bye.